Znači, moje ime je Davor Runjak, ja sam došao danas ispred kompanije Combis Technologies, jednog nego sigurno novog imena. Naša kompanija je u stvari sa headquarterom u Londonu investirala kroz ovo vrijeme u Hrvatsku na način da smo oformili tim koji se bavi upravo ovim problemima ili, ja bih rekao, novom hajpu zvanom Big Data. Znači, danas bi vam htjeli prikazati da možda Big Data još uvijek nekako zove da je Big Data kao seks u tineđera, svi o tome pričaju, a nitko ne prakticira. Mada nama se čini da su se stvari dosta promijenile, da trendovi pokazuju da stvarno postoji monetizacija i danas nam je ideja u stvari pokazati nekoliko stvarnih caseova upravo u vašoj bankarskoj industriji i u stvari vam dati viziju kako drugačije gledati na pogled toga da podataka imamo previše, a u stvari ne znamo što ćemo s njima. Ono što možemo samo kratko reći o nama je da smo u kontekstu onoga što radimo razvijamo vlastito Big Data Analytic rješenje koje ćemo sigurno u širem krugu najaviti u javnosti Hrvatske. Do toga da partneriramo sa nekoliko bitnih partnera, a danas smo pozvali kolegu iz Teradate da nam detaljnije ispriča konkretnih slučajeva upravo u bankarskoj industriji. No ako vidimo ove naše poslovične partnere, ja bih samo skrenuo pažnju i na Aptitude Software i na nešto što u vašoj industriji sigurno dolazi, to je IFRS 9. Neki od vas će se možda i naježiti na sam spomen IFRS 9 regulative koja nam dolazi 1.1.2018. i sigurno će napraviti veliki impakt na ono što vi danas radite i način, na ono što je Ivan spomenuo. Znači, ta promjena koja dolazi, znači, htjeli bi vam neko dati do znanja da mi kao Combis Technologies jesmo spremni i tu promjenu koja je uvijek teška probati prepoznati što je moguće ranije. Ne? Što se tiče drugih partnera, mi smo i partneri informatike za Europsku ekonomsku regiju. Informatika je inače također lider u Gartnerovom kvadrantu, no uglavnom samo kratko, ideja Combis Technologies je da partneriramo sa vendorima koji su prije svega nezavisni i koji stvaraju u principu domenu najbolje pozicioniranih i vodećih u svom segmentu. I time u stvari dolazimo i do Teradate kao našeg ključnog partnera kojeg vidimo kao veliki potencijal i nešto što možda u ovoj regiji nije bilo toliko prisutno. Znači, postala je ta klasična fama da je Teradata preskupa, da je Teradata za američko tržište. Htjeli bi na neki način donijeti tržištu i demistifikaciju takvih jednih pogleda. I na kraj krajeva, evo, još jednom vas pozdravljam. Prepustit ću kolegi Štefanu da vam pokaže nekoliko stvarnih caseova i da na neki način, evo, pozivam vas da postavljate pitanja, bit će vrlo konkretno iz bankarske industrije i danas smo ovdje cijeli dan, potražite nas, pitajte pitanja. Hvala vam lijepo.
Yeah. Hello, good morning from my side. First of all, I want to say thank you, Ivan, for inviting us and giving us the chance to present here.
Help you?
Oh, great, thanks. My name is Stefan Ruland. I'm an industry consultant for banking at Teradate, based in Vienna, working with banks across Central and Eastern Europe, banking groups like UniCredit, Raiffeisen, Erste Group, but also, for example, Sberbank Europe. And today I will give you a very brief presentation on big data in financial services. What are our beliefs, how big data can support banks, what are interesting use cases successfully delivered at leading banks globally. What I want to mention, the presentation is pretty comprehensive. We have quite a lot of use cases, so I will go through the use cases pretty quickly. In case you have any questions, please do not hesitate to interrupt me. Worst case is that we have to clarify this afterwards, but happy to answer all the questions you may or may not have. Okay. Yeah, very few words on who is Teradate. You may or may not know us. Teradate is a leader, long-time leader in data warehousing and big data analytics. I think in the Gartner Magic Quadrant, we are in the leaders quadrant for 10 consecutive years now. But we are also growing rapidly in the big data area. Last year we delivered 25 projects across Europe, and in 2015, looking forward, seems that we have managed to double the number of projects delivered successfully at customers. We do not only grow organically, we also grow through acquisitions. Quite recently we announced that we again acquired a big data analytics and consulting company, but I do not want to bore you or bother you with our company numbers. I personally think that the use cases are much more interesting. A few of the big data references we have, and you see the large well-known brands, be it Bank of America, HSBC, Royal Bank of Canada. And this raises one question: is big data only for big multinational banks? And clearly say no. Well, there are a few use cases where size actually matters, but most of the use cases, in particular those use cases I will present today, can be delivered at banks or of all sizes in all markets. What is our big data approach? What does big data mean? And to me, you all know big data, we always talk about volume, velocity, variety of data. True, to a certain extent. But what big data actually is about is analytics and the culture of analytics. And I will come to this in a minute. Big data means that you have to at least slightly change the approach you apply. And most of the use cases I've seen so far, I'm wondering myself, okay, what exactly is now big? The volumes aren't so big, the data is pretty well structured. It's rather the analytical approach, the analytical culture that has changed or is changing, is constantly changing and is disrupting the market. When you see how does a typical discovery process look like, and again, way too many details for the time we have, I want to point out only two aspects. What we see in each and every project we've delivered so far in data acquisition and preparation, loading and transforming data, this is where you not only spend but waste most of the time. So this is a threat, a challenge, a burden, because it usually limits the time you have for analytics. So if I could only give you one recommendation, put lots of emphasis on this aspect of loading and preparing data properly. Otherwise, you will simply run out of time to do proper analytics. Okay, well, I am supposed to have such a slide in here. Again, I do not want to spend many words on all the architecture components and platforms we have, because my true belief is big data is not about technology, it's about analytics and the culture you apply to it. This is also why I do not want to bore you. What is really one important aspect, you see on the top side how typical data warehouse delivery model looks like. Long release cycles, expensive projects. This simply doesn't work in the world of big data. Big data discovery needs you to embrace and apply different concepts and approaches. You will see many projects, smaller projects, often funded from run the bank or business as usual budgets. And those projects have a different risk-return profile, whereas you can't run the risk that a large data warehouse implementation fails. Whereas in the big data area, you have high risk, high reward. You have a different approach because what you see, lots of, sometimes most of those projects and initiatives will fail. And fail means it turns out that the data does not deliver the value you expected, that the hypothesis you initially had, simply it doesn't pay off. You cannot see the patterns you expected to find. Okay, you turn down this hypothesis, you move on to the next one. It's applying different concepts. What you nonetheless have to do, those projects who have proven value will have to be integrated in a stable and strongly governed environment. So those two worlds, warehousing and big data, are not separated, they are converging. But you need different approaches, you need different ways how you address issues. But most important, they are not so separated. now I'm all on us and what we think is our belief. I want to come to the use cases. And when preparing for today's presentation, I tried to get an update on the Croatian banking market, what has changed. Well, it seems to me that the situation is still pretty challenging. At least this is what you can read in all the economic research. So I tried to find use cases that have already been implemented successfully at other banks and that make sense in your market. For example, social media analytics does not make much sense in a country that has 4 million citizens. In Austria, when we did this for a bank, 1.5 million retail customers, and guess how often this bank is mentioned on Facebook or Twitter? Well, you would not even need 2 hands to count how often such a bank is mentioned on Facebook or Twitter. So this is not a proper use case for big data analytics in markets like Croatia or Austria. What I want to bring to your attention are 2 use cases about how to attract and how to retain customers, how to accompany a customer on his customer journey. When talking about banking use cases, what we see here is what we call a big data business value framework. And you see on the left-hand side areas, marketing, customer experience, risk, fraud, and so on. And what I want to point out, these are not ideas, theoretical concepts. Every box that is green are use cases that are up and running, set into production, really working at customers. Orange or amber still means we have a proof of concept or proof of value conducted. The only one that is white is just an idea for the time being. And those, what you see in the market, use cases, the most successful use cases come clearly from the marketing area. Topic number 2 is, I would say, fraud detection, fraud prevention. Number 3 is already how to improve credit risk, default detection, and other risk-related topics. Yeah, customer journey. The use case we have here is, sorry, a little bit too fast. The use case we have here is from a large banking group in the UK. And what you see on the top-hand side, the customer journey, how the customer clicks through the websites, through the different sites on the website. In this case, it's about remortgaging, so the customer wants to refinance his maturing mortgage. And you see, how does the data look like? How does all the clicks on the website, how does this translate into data? It's what you see on the left-hand side here. And this is what you currently hardly see in the classical relational databases. You can get it in there, but it's a lot of effort. But the information you can retrieve is actually valuable. You see how much time he spent on, where's the customer interested in? He spent this and that minutes on remortgaging. And well, when I had this the first time, I said, can't work. But then I had to realize not everyone deletes the browser history when closing the browser. So it actually works for lots of customers, because you can also see, okay, 2 weeks ago, he visited the website, the Get Married financial advice site. So you get lots and lots of information you would usually not be able to capture in a classical relational database and analytical world. And look at this. In the meantime, I think every bank has a loan or mortgage calculator on the website. And lots of customers are trying, what if I have a maturity of 10 years? What if I have a maturity of 15 years or somewhat in between? What the customer actually does, it gives you lots of information you can act on. Because you see, the customer may be happy with the loan amount he wants to apply for, and may be happy with purpose and so on, but not sure about the maturity. What does this mean? He's maybe not sure about the affordability of the monthly installment. And this is information the customer more or less subconsciously provides to you, information you can analyze and act on. And what is the value to you as a bank? Of capturing this data provides you endless opportunities to interact with the customer. whatever the customer does on your website, you can use this information to generate leads for your branch network, for your call center, for your sales force. And based on it is a large UK bank, means it's from Lloyds Banking Group, this had increased conversion rates by 40%. So this can be easily translated into a dollar value or a euro or kuna value, whatever currency you want to see there. But raising the conversion rate by 40% can immediately be translated into hard cash. Another example, and this is from, I think, the largest Australian bank we have as a customer, different ways of visualization, the process of customer applying for a loan or wants to have a loan quotation on the website, and particularly where you then risk to lose the customer, where the customer abandons the process, and also gives you the chance to find out why you lose the customer from the application, loan quote requests, affordability, and entering the personal details. So all the data, yeah, you can bring it into a classical environment, but it would simply, from an economic point of view, wouldn't make sense. You would have to spend way too much time on preparing, loading, analyzing the data if you want to force this into classical structures. What you have the advantage is that the data is actionable. But what I actually want to turn to, this is maybe the most interesting aspect, and see where you lose the customer in detail. And it turns out, this is from the analysis we did with Westpac, in case the customer does not update his personal details, the accept rate is 27%. In case the customer does the update on the personal details, the accept rate was 36%. So what does this mean? They tried to implement a process that motivates the customer, forces the customer to update the details, because then he usually get a better risk-adjusted pricing on the loan he is applying for, and just closing the gap between, only for online applications, closing the gap between 27 and 36% translates into more than 5,000 additional loans per year, which equals roughly $3 million profit. Okay, you would have to adopt those, would have to adapt those numbers for your local market, but this is also a use case where the value can be proven pretty quickly. Yeah, okay, now we spent a few thoughts on how to attract the customer, but it's maybe as important as winning a customer is to retaining customers, because usually it takes you 3 times the effort or the cost to win a customer than just to retain a customer and keep customers happy. So I would expect you to say, okay, we already have churn models. We have it in SAS, SPSS. Fully agree. What do you do in those models? They're usually statistical models where you have some kind of discriminatory analysis, some logistic regression, and big data will not replace those models. It's rather about complementing those models and increasing the quality of the predictions, and also generating new input factors that can be used in those statistical models. So it is not, is it SAS or big data? It is rather not an or, but an and. So use both to increase the predictions and the quality of the models. What you see here, an event churn. What happens before the customer churns, before the customer closes the account? And this is, yeah, a typical visualization of such a graph analysis where I see all the different events that can occur, and which events in which sequence have occurred before the customer says, no, now I close my account, goodbye, I go to the other bank. So you see many events like call center, service complaint, or online review statement, or bank commission reduction request. So most of the events seem to be pretty obvious. A customer that is constantly complaining, would you be very surprised if this customer closes the account? Usually not. Yeah, true. But to do this analysis for all the customers you have, all the accounts the customers have, cannot be done by applying, by being intuitive. You need analytical support for this. And, oops, so in this case, sorry for that, the animation went wrong. This is a screenshot from our Discovery application, where you see, okay, this kind of graph analysis, or path analysis, and path. This is maybe the most prominent analytical technique, the most prominent analytical pattern applied. We always say our big data platform has more than 100 predefined, prepackaged types of analytics. That's true, but in fairness, maybe 50% of the successful use cases somehow apply this kind of graph analysis, but it turns out to be really helpful, so why not? And what you can see immediately is what are the most important part. What is the most important part? Which events happen in which sequence before the customer decides to close the account? And this data, again, bring it to the classical relational database, would be quite burdensome, it's not inconceivable, but the effort you would have to take simply makes it, from an economic point of view, totally pointless to try such an exercise. So, and surprise, surprise, a commission reduction request and a service complaint seem to be signals. Again, okay, this is something I would know intuitively, true, but to do this analysis for all the accounts you have in a bank, you would need lots of resources with lots of intuition. And what it is actually about is to identify the most common event sequences, what is also called golden path. You see here, and this is maybe a really nice feature in the tool, when you can filter on the path count to immediately see what are actually the sequences you would have to focus on, where you have to put the emphasis on, where you have to maybe use the triggers you get from the customer earlier, maybe where you have to change processes, where you have to generate new input factors used in the statistical models you anyway have. Because the actions you can take are manifold. You can, for example, in case the customer complains not only once but a second time, you can combine this with data on customer and lifetime value you may or may not already have to start different actions than you would do. You can use those patterns also as input into existing models, or, and this is, to be honest, what you do not see that often, you can also create new predictive models. But but most of the successful implementations, you will see a change of the business rules, and you will see that those analytical results will be integrated or embedded in the statistical models you have. Let's jump into one additional use case I have, and when preparing for the conference, I also see that the non-performing loans in the Croatian market, unfortunately, still increasing, or at least not decreasing. So credit risk is maybe also a use case that could be of interest to you. And what also applies as for churn, it's not about replacing the statistical models you have and you need to have, for example, for regulatory purposes. A regulator will insist on the classic statistical models he is used to, and it will take quite a lot of time before the regulator opens the eyes and the mind for new approaches, but we'll come to that point. Quite recently, I could attend a conference about big data in central banking, and don't know how this is in Croatia, but some of the central banks in the Nordics and Western Europe are changing their mind in this respect. What you will also see, and this is a use case maybe even more relevant because it's not from a large US or UK bank, but from a bank in the Czech Republic, so also a Central European market, a fairly small country, and maybe therefore closer to markets like Croatia or Austria than the United States or the United Kingdom. And again, not replacing the existing models you have, but rather increasing the prediction the models can make. So, and what you see here, this is from I think it's JSOB, which is a subsidiary of KBC, the large Belgian banking group, where they did some analysis on the correlations between the account balance and default. So how did the account balance of the customer evolve over time before the customer defaulted? What you see on the left-hand side is it is clustered in terms of the balance. Is the customer, does he has a credit or debit balance on his account, and how does this move over time? For the transaction path, a usual time period is 1 month, but in the analytical process, you have to test this a little bit. What turns out to be useful, and you build this kind of clusters. Depending on the account balance, maybe has a balance of, I don't know, between the upper boundary is, let's say, 1,000 euro, the lower is minus 1,000 euro, and you see in which cluster the customer is for which period of time, and how often does this change. And then you see from the customers who have actually defaulted, you see how was their behavior before they went belly up. Statistically, it's this kind of simple aggregate approximation, and yeah, you see particular transaction path which gives you a clear signals on default probabilities. And if a customer is already here, this type of analysis creates signals you can use to act before the customer goes belly up. So you will not be able to prevent each and every default that can occur, but reducing defaulting customers only by a fragment of a percentage can drive your P&L significantly. I see we're at the end of the time I have. All I want to say is, again, thank you for giving us the chance to present here. I would have another boring slide on our service offering in case you're actually interested. Happy to talk you through in the next break. Otherwise, thank you for your attention.